Hello, check. Alright, let's start with problem number 1. You are given an integer array nums. No breakpoints, brother. Okay. You are given an integer array nums. The unique elements of an array are the elements that appear exactly once in the array. Return the sum of all the unique elements of the array. Okay. I mean, you can always use a hash set or something like that. Let's start with that. So set of integer set equals to new hash set. Okay, now for each num in nums, if set doesn't contain the number, then you would do okay. Then sum plus equals to the number, and then you add this number to the set. So each number will only be counted once. Return sum. The space complexity is O of unique O of n, for simplicity. Time velocity is O of n, but for every n we are also calculating a hash set. The calculation of that hash is sort of okay, some O, so O of n space, O of n time complexity, whatever. Directly submit, and you get a wrong answer. Overconfident, I guess. So case 1, 1 2 3 2 unique elements are 1 and 3. Okay, so what it is saying is numbers that are not repeating. Interesting. Okay, so the problem statement is wrong, or if we understood it incorrectly. Then we need the count of each element. If map dot contains key number, I mean not even this nonsense, it's very simple. Map dot put num comma 1 plus map dot get or default num comma 0. So that's that. Now you go through for each number in map.eset, map.get num. If it's equals to 1, then sum plus equals to num, and you return the sum. Okay, submit now. Right, problem number 2. Too big problem and whatnot, but let's read. You're given an image represented by ampersand grid of integers image, where image ij represents the pixel value of the image. You're also given 3 integers, so sr, sc, and color. Your task is to perform a flood fill on the image starting from the pixel image sr, sc. To perform a flood fill, begin with the starting pixel and change its color to color. Perform the same process for each pixel that is directly adjacent, pixels that share a side with the original pixel either horizontally or vertically, and shares the same color as the starting pixel. Keep repeating this process by checking the neighboring pixels of the updated pixels and modifying their color if it matches the original color of the starting pixel. The process stops when there are no more adjacent pixels of the original color to update. Return the modified image after performing the flood fill. I don't know what it means. Okay, so color is represented by some number. You are starting with this, so you change it to 2. You change this color to 2. and then everybody who is adjacent to it. I mean, can we be honest about one thing? Everybody is adjacent to it, no? Like, okay, so you can't change this one to two, interestingly, but you can change all of these ones because they are connected, right? You do have to find the connected component first. So you have to find the connected component first, and then you have to change that connected component um, to whatever you want to set it. So how do you find the connected component? You go through each and every number, and you would I start with this, and I go in all the four directions. Plus one, minus one, plus one, minus one. Only four cases, and I connect it if it is equal. I connect if it is equal, and things like that. So this is not connected to this because it got broke. Okay, let's look at another problem down. I don't think it's an easy problem. It's a medium problem, which is why I think it's taking me a little bit of a time. But that's okay. Python is easy, yeah, but I do it in Java. Let's do brute force. This is our original color, and what do you say, like maintain like a visited array or something, right? Let's create a visited. So boolean okay, and it will be initialized to nothing is visited, which is fine. And then what do you do? What are you gonna do? Let's call it DFS. Yes, okay, if you say so. So DFS of, you're gonna say image, you're gonna pass SR, you're gonna pass SC, what else you're gonna pass? Color, and too many things visited, so that's okay. Image, SR, SC, color, visited, and original color. Yes, so you do this, and then you do return the you change it to in this image itself. Yeah, this is what you do. So now let's say void DFS image int SR. Okay, now what are the breaking conditions? Well, one breaking condition is wherever you are, this SRSC, if SR is less than 0 or SC is less than 0 or SAR is row is greater than image.length, well, not greater, even equals to, right? Column is greater than equals to, or you have already visited it, so visited of SRSC is equals to, in all of these cases you just return. Otherwise is, and not just that, if you're not connected, then also you don't do a thing. And what that means is image of SRSC, if it's not equal to well, I would say there is a problemato. Yeah, there is definitely there is definitely a problem, but I'll come to your problem later. But okay, let's do this. Image of SR SC is not equals to original color, then also you don't do nothing. Okay, now when you come, you would first thing you do market visited and change its color to the new color, and then do a DFS on image SR plus 1 SC color visited original color, and you have to do this 8 times. So sorry, 4 times, my bad 1 2 3 4 SR plus 1 SC plus 1 SR minus 1 C minus 1. Is that what you do? What's the time complexity? Well, it's whatever, this m cross n times 4, each could be visited some number of times, so but O of m cross n. And yeah, let's run and let's submit. Alrighty, this works fine. Let's move on to the problem number 3. Most frequent number following key in an array. This is our problem number 3 of the day. You are given a 0 index integer array nums. You are also given an integer key which is present in nums. Okay, so there is a 0 index integer, and there is also you are also given an integer key which is present in nums. Fine. For every unique integer target in nums, count the number of times the target immediately follows an occurrence of key in nums. In other words, count the number of indices I such that I is 0 or nums of length minus 2. Okay, nums of I equals to key. Okay, and nums of I plus 1 equals to target. Return the target with the maximum count. The test cases will be generated such that the target with the maximum count is unique. Let's understand. Here key is 1. So after 1 you're getting 100. After 1 you're getting 100. So 100 occurs twice. For target equal to 100, there are 2 occurrences at indices 1 and 4. Okay. Here key equals to 2. 2, 2, 2, 2, 2. For target equals to 2. So after 2 I get 2. After 2 I get 2. After 2 I get 2. So for target equals to 2, the count is 3 occurrences in indices 1 and 3, and for target equals to 3 there is only 1 occurrence. It's a very weird problem statement, but it's an easy solution, I think. I can maintain a map. Should I maintain a map? Start with the map and then see if map's required or not. So map, I want the largest one, right? So maintain just the largest one, no? Okay, that's what you say. Int target equals to yeah, how would I know, right? Yeah, I will have to maintain a map. Okay, let's maintain a map, brother. Map teaser map equals so if nums of I equals to key, if that is the case, then I'm gonna put map dot put nums of I plus 1 plus map dot get or default nums of I plus 1. Okay, so you get the target count and whatnot. And you can also, I mean, you could avoid one pass, I guess. It wants a target or it wants the count of the target. What does it want? Okay, it wants the target. I think I can maintain it, no? It's and I'm guessing there will be a target. What if there is no target possible? What if there is, then what do I return? Target is maximum. So the test is the target with maximum count is unique. Okay, whatever. The target equals to max value. Disturbance, whatever. Apologies if there is any one, which I don't see any, but that's okay. Int max equals to 0, target equals to yeah, max equals to 0, no? That's fine. Yeah. Okay, let's run. And submit. Alright, problem number 4. Problem number 4. Given an integer array gifts, किसको गिफ्ट मिल रहा है भाई? Gifts, take gifts from the richest pile. We are given an integer array gifts denoting the number of gifts in the various piles. Every second you do the following. Choose the pile with the maximum number of gifts. If there is more than one pile with the maximum number of gifts, Okay, choose the point of the maximum number of gifts. Done. If there is more than one point of the maximum number of gifts, choose any. Okay, reduce the number of gifts in the pile to the floor of the square to the floor of the square root of the original number of gifts in the pile. Return the number of gifts remaining after k seconds. Some complicated stuff, I guess. Let's see here. Okay, 25, 64, 9, 4, 100. 100 is the maximum pile, you know. Gifts are taken the following way. Now, in the first second, take the last pile is chosen, okay, and 10 gifts are left behind. What do you mean the left behind? Reduce the number of gifts in the pile to the floor of the square root of the original number. Okay, 100 square root is 10, so your 10 is left behind. Then 64, 8 will be left behind. Then okay, 10, 8, 25, 5 will be left behind. One more we have to do. So 5, 8, 9, 4, 10. You'll take that 10. 10's square root is nobody knows. Whatever. Okay, 3 gets that. And the final. Okay. Okay, babe. That's what you wanna do. You do that. Priority queue. Priority queue. Let's use priority queue. We want max priority queue, right? So you pass your constructor in an opposite way. Instead of a minus b to b minus a. Now this is your max priority queue. Now you have to do something k times. What do you have to do things k times? Hello Hemant. I equals 0, I less than ki plus plus. Alright, so for every time you remove one element from the priority queue and you take a square root of it and you floor it. Now this is where I will need math functions. Okay, now let's use Java docs. Java docs math.sqrt is what I need. Let's see what it says. I think this much should be allowed. This is not exactly cheating. I don't know. I am cheating, but okay. Square root. So you have to pass a double, then you get a square root. Can you pass something else? Probably not. Okay, correctly returns the correctly rounded positive square root of a double value. We'll use math.sqrt and we'll figure out what to do. Okay, so we'll do. Wait, is it int the right thing? It was long here, and the gifts are int. Okay, so it's int only. Sqrt of x. Now what whatever you will get, rounded positive square root of a double value. You will get a square root, and then by default when you do int it will take the floor. Yes. You'll add this. Does that work? I don't know. After the end of it all, you will do what exactly? You will do sum is 0 and this is not int, this has to be long. So you do sum equals to sum plus, you remove an element from the priority queue and then you return the sum, is it? Let's see. I'm sure there will be some compilation errors because of typecasting, but that we can fix. Okay. Possible lossy conversion, yeah, from double to int, yeah. So I will do this. Type conversion is fine. Alright, submit. This is our problem number 4, okay. And it works. Move on to problem number 5. Problem number 5. Intersection of multiple arrays. Given a 2D integer arrays nums, should I actually use, I can't we see, but I'll start a timer, okay, so that I'll know how much time I spent on a problem. Let me see if I can add it. Give me a sec. Yeah, this should be fine. The timer is visible, hopefully. And this is perfecto. Okay, now I'll know how much time it took for a problem. Intersection of multiple arrays. Given a 2D integer array nums, where nums of I equals a non-empty array of distinct positive integers, return the list of integers that are present in each array of nums sorted in ascending order. What do you mean, bro? What are you saying? Okay, it's a 2D integer array, and nums of I is a, okay, so here you can see there are 5 elements, here you can see there are 4, so it's not like a homogeneous sort of thing. You can have multiple sizes, multiple 1D size, multiple sized 1D arrays within the 2D array, okay, but it's non-empty. Return a list of integers that are present in each array of nums sorted in ascending order. Number of integers, okay. So for example, whatever, output is 3 comma 4. Oh, each array. So in the first array it's 3 4, in the second array it's 3 4, in the third array it's 3 4. Now I'm getting it. You have to find the intersection that is fair. How can you do it? What are the ranges? I guess that depends, you know. What are the ranges that are given? Nums of length is 1 to 1000. Sum of nums of length, I of length. All values are unique. Each value is in the range 1 to 1000. There are some hints here, I feel like. See, each array will have a unique value. So then I can just have the count. I mean, I can just maintain like a map, and I don't need to have multiple maps. I can have a single map. And for all the elements, and nums of ij are just 1000, right? So I don't even need to create a hash map. All I'll do is this count just a new int of 10001, just 1001, right? So 1 to 1000. Now I'm sorted. I'll just go through the list, add the count, and everyone's whose count is equal to nums.length. Okay, so for each integer array, for each row in nums, for each num in row, count of num plus plus, as simple as that. So now I've gotten the count. Now not just that, you don't have to do a second parsing. If count of num is equals to nums dot length, okay, this it needs sorted. That's fine, I'll sort the list later. I mean, that's a tricky one. Do you want to take time to sort and log in, or okay man, okay, whatever, fine, I'll keep it simple because it needs it in sorted fashion. I won't add it now, I would add it later because it will take less time than sorting. So this is fine. Now I'm gonna do is for each, for int I equals to 1, I is less than equals to 1000, I plus plus, if count of I is equals to nums dot length, then list dot add I, and then you are gonna return this list. But where did we define this list? We haven't. We will define. So list of integer list equals to new array list. Okay, run baby, run. Problem number 5, let's see, it doesn't compile. Let's fix the compilation error. It is an integer, it is not an array. Okay, run again. Submit. Folks, hope it helps a little bit. It's live and raw. I make mistakes, you see my mistakes, you learn from my mistakes or whatever. Let's do the problem number 6 now. Whoever is here, where are you from? Longest palindrome. Given a string S which consists of lowercase or uppercase letters, return the length of the longest palindrome that can be built with those letters. That is a case sensitive. Oh, so I did the last one in like 5 minutes. Is that what it is? Let's restart it. 5 minutes is too much for an easy problem. Do it in 2 minutes, bro. Alright, given a string S which consists of lowercase or uppercase letters, it is the length of the longest palindrome that can be built with those letters. That is a case sensitive. For example, A is not considered a palindrome. Okay, case sensitive है. Longest palindrome, string S. Length of the longest palindrome that can be built with those letters. Okay, so these are the letters. What is the longest palindrome that I can build? Okay, so you can either build an even length palindrome or you can build an odd length palindrome. Okay. So A is only 1. So 4C, whichever has even number of occurrences, there you just count all of them. Okay, so this is what 4C and 2D, which is even, which is what 6 by 2 is 6. Yeah, so you can create any palindrome from this. Then you can take one odd letter. Whichever is even number occurring even number of times, you take it. Sum there and then take now the ones that are occurring odd number of times, you have to place it in a perfect position, right? So if there are, for example, A and B doesn't work, but if you have fuck this shit, bro. Let's first get the count of each character. Yeah, so what, lowercase and uppercase, that's it. Yeah, okay, let's just maintain a set or map, yeah, map character integer, let's call it count. Count dot put C 1 plus count dot cat or default. So now we have the count of each character. Yeah, don't confuse so much. Whichever is even. And then you can add 1 to it if you wanted to, right? If there is something left. Okay, now go through each, for each character in count.get see, and then if there was any odd, that means उसका जो एक है वो हम बीच में कहीं भी फिट कर सकते हैं, right? So you do this is it, nothing else, nothing more. Hopefully it works. It doesn't. Compilation error we fix. Some more compilation error. What is this key set? It's the key set. Alright, submit. Yeah, you took 5 minutes 34. You took too much time. Don't like it. Also, time complexity isn't that great, but I mean, because I'm using a map, you could probably do it in some other way. I will be happy with this and move on. Problem number 7. Check balanced string. We're given a string num consists of only. You are given a string num consists of only digits. A string of digits is called balanced if the sum of the digits at the even indices is equal to the sum of the digits at odd indices. Return true if the num is balanced, otherwise false. 1, 2, 3 and 4. 1 plus 3 is 4, 4 plus 2 is 6. It's not balanced. Okay. 2 plus 1. 2 plus 1. 2 plus 1 is how much? 2 plus 1 is 3. 3 plus 3 is 6. 4 plus 2 is 6. Yeah, it's balanced. Man, come on, who gives a character, brother? Just give an array for each character. I can't even do this. I have to maintain the indexes correctly. Alright, how do I get this n? That's the problem. That's the real problem. How do I convert this character into the digit d? Huh. Some parsing function, does it exist? Let's try. Does it even work on character? It's not as. What is as? It's a num. So no, it doesn't work. How do I convert this character to its appropriate integer value? I guess I do it by subtracting it with the can I do this? Something like this, and then typecast it into an integer. Maybe this, yeah. Let's run. Alrighty, it works. Does it pass? Does it pass all test cases is the question, and it does. Let's move on to problem number 8. Problem number 8. Set mismatch. You have a set of integers s which originally contains all the numbers from 1 to n. Unfortunately, due to some error, one of the numbers in S got duplicated to another number in the set, which results in the repetition of one number and loss of another number. Yeah, so sad. You are given an integer array nums representing the data status of this set after the error. Okay, find the number that occurs twice and the number that is missing and return them in the form of an array. Okay, 1 2 2 4. What happened was we had 1 2 3 4. And then suddenly 3 disappeared and 2 repeated. Okay, so now it's clear. So one of the things that I can do here is I can do a sum. So if I do 1 plus 2 plus 3 plus 4, I mean I don't even need to do a sum, is it? I mean I can just go through the array. I know, because an integer set of integers s which originally contains all the numbers from 1 to n. Unfortunately due to some error, but so yeah, so I go through the array, I see which number is repeating. That is a repeating number. That's as simple as that. And then I also find a number that is not present. How do I do that? And then the thing is, can I do it without extra space? Because you can take in space into whatever you want, but can I do it without space? I could do something which is I can modify the presence by some hacky wacky way. Yeah, that's what I'm talking about. Okay, so you want to do in place marking so that you don't take extra space. Okay, I will try to do it in O of n time, O of 1 space. So this is what I do. I equals to 0, I less than nums dot length, I plus plus. Is it given like a sorted fashion or something? Nothing like that, no? Okay, doesn't matter. So whatever the number is, right, put it at a specific index. Whatever the number is, this is the number, and which index would it be at? It would be at val minus 1, correct? So if nums of index for this val, if it is already negative, that means, so basically I'm doing negative, I'm marking it negative. So if it is already negative, that means it is the one that occurs twice. So That's it. Else you mark it. Yeah. Another thing that you have to do. No, you don't. Which is you have to take the absolute value of it. Okay, so here, right? Yeah, here you have to take the absolute value because you might mark it negative. Okay. So this is fine, this is fine, this is fine. You've done through all. And by doing this exercise, the number which is not negative is the one. Okay, so now you go through each number for each integer I equals to 0, I is less than nums dot length, I plus plus. If nums of I is not 0, so this is a missing number, is I plus 1, because I plus 1 would be at index I, would have been marked at index I, negative marking. So tricky. Okay, dokie. Now you have to return it as an integer. So what you do is return new int. First is what? Missing or duplicate? First is duplicate, and then the missing number. Run the code. Man, fix your compilation issues, brother. Cannot find symbol. I defined it, no? Here, index for val. Okay, your casing is an issue. Minor thing. Okay. We're doing problem number 8 and we're having issues with fixing our casing. Problem number 8, let's submit. Missing and repeating, yes sir. And we are done with missing and repeating. Now we're moving to problem number 9. Okay, count partitions with even sum difference. You're given an integer array nums of length n. Partition is defined as an index I, जो कि बीच में कहीं है. Splitting the array into two non-empty subarrays, important. The left subarray contains indices 0 to I. Yeah, all this is basic stuff. Return the number of partitions where difference between the sum of the left and right subarrays is even. Man, why are you making it so hard? You would need the sum of different what do you say, you would need the sum of different subarrays. That means you might want to have like a cumulative sum so that it makes it easier for you to get the sum of index sum index, right? So let's do that. Let us do that. And I don't think I need a separate array for it. I can modify nums itself. So this is just, I think I have to do convert nums to cum sum. Yeah, so for int I equals to 1, I is less than nums dot length, I plus plus, nums of I plus equals to nums of I minus 1. That is it. So now I have a cumulative sum. The reason of cumulative sum is, now if I want to know the sum from whatever, let's say 1 to 2, it's a cumulative sum at 2. If I want to know the sum from x to y, right? So the thing that why it helps is this: sum from index I to index j is, well, it is cumulative sum of j minus cumulative sum of I minus 1, right? And if I is 0, it's a special case, then you just do this. Okay, but you got the gist, right? Now what do you have to do? So we have to get the we have to divide the array in different partitions. All partitions we have to see. Okay, so we have to see all partitions. So at least we'll have to have one element on the left, right? And then we'll just shift like that. So that's what we'll do. So for int I'll call it partition p equals to, it will be at index, let's say partition is the last element of the left array. Let's say that's a partition. So then p equals to 0. And if that's the case, then because you have to have non-zero, then the last way I partition, then p would be, can't be at n minus 1, because n minus 1 is then means there is no right array, so it's n minus 2. So p is less than n minus 1. So p is less than, oh man, less than nums dot length and p plus plus, which is fine. Now let's get the left sum. Left sum equals to nums of, left sum is easy, nums of p, is it? Yeah, that's it. And right sum equals to nums of nums dot length minus 1 minus nums of p. Yeah, exactly. Cumulative sum till here, cumulative sum till here. Okay, so left sum, right sum I got. And I think you would want, I don't know if sum exceeds, what is the size of these nums? Yeah, these are very small. Okay, so what is it saying? The right difference and left difference, some of the difference between the sum of the left and right subarrays is E1. Anybody can be bigger, but it has to be E1. If left sum minus right sum percentile 2 is equals to 0, count plus plus, count equals to 0, return the count. Any feedback appreciated. Am I too slow? I'm too fast? Am I dumb? Case 1, case 2, case 3. Bunch of one time are failing, brother. Okay. Why is it failing? I can't have it fail. What is case 2? Case 2 is this. Case 2 is 0. Okay. 0 is always the easy answer. So you're always doing 0 every time, is it? No. You returned 5 here. You return 0 here. So you're returning 1 extra. Okay, I'm returning 1 extra. Yeah, I think I said it has to be minus 1, brother. Did I not say it? Yeah, you did. So what happened? Alrighty, submit. This was our problem number 9. We did it pretty good in time and space. Last problem. Let's have some energy. Last problem. How many numbers are smaller than the current number? How many numbers are smaller than the current number? So simple question. Given that the array nums for each element in the array, how many numbers are in the array that are smaller than it? That is, for each nums I, you have to count the number of valid j's such that j is not equal to I and nums of j is less than nums of I. Okay. Can't I sort it? Can I sort it? I mean, you can do it in n square. For every element, go through the array, right? And other thing is you sort it. You take extra space, you sort it, and then what? Well, then you got the answer. But okay, you can always sort it with the index. That's what you want, because ultimately, okay, wait, hold on. So what is the output looks like? The answer is an array. How is the answer an array? So when I'm saying 8, the question is how many my question is 0 1 2 and 3, so 2 and 3 will have exactly same output, right? And 2 there exists one. Okay, I would sort it, man. Okay, let's copy the array. Equals to new int of nums dot length. For int I equals to 0, I is less than nums dot length I plus plus array of I equals to nums of I. I think you want it with the index, no? Do I not want it with the index? Okay, I'll have it with the index if you want, if you are so desperate. Okay. Yay, I've sorted it. Now what? Okay, now I have to be very careful. How do I navigate it? It is tricky, baby. Okay, so for int I equals to 0, I is less than dot length I plus plus. Now I'm looking at a sorted array already. Given that I'm looking at a sorted array, so given that I'm looking at a sorted array, I have to see what was the when was the last value same as this previous value, and I have to maintain that. It's very important that I maintain that because of the duplicates. Yes. So, but here's the thing: result of array of I of 1. This is the index. Number of elements smaller than this is 0. There are no elements smaller than this. That's not true, right? If it was a equals to I, if there were all the elements were distinct, it would have worked brilliantly. Problem is the elements are not distinct. There can be unique elements as well. So I can do simply, I mean, I can have 2 loops within it, but it's not really 2 loops. I mean, it looks like, oh, 2 loops is n square, but it's not. If you actually see what the loop is doing, right? So do you want to do that? Yes, I think. Or you could be slightly smart as well. And let's figure out what can I do. So if I equals to 0, then it's just this, nothing else, nothing more to do, no comparison. Else I think you have to keep j. Yeah, j is another idea. J is a bun. That's the tricky bit. So basically, if array of I 0 is equals to array of I minus 1 0, then what happens is j doesn't increment, and if they are not equal, if it's not equal to this, then j also increments. You can always do, yeah, this doesn't matter, and then you do is this is at j. I think to make it more simpler, I can do now when I is equals to 1, for example, and do I do j plus plus or do I do j equals to I? I can also do something even simpler. If I is 0, then it is already true, so j is equals to I. Or that means that I is not equal to 0, then I is equals to 1 or something. Okay, whatever. Let's return result. I'm a bit confused. I think people also were. They've left. And it doesn't compile. Well, at least compile, bro, though. Okay. Alright, it's just it works, yeah. And this was it problem number 10. I think this was problem number 10. And it's worked. Alrighty, I'm happy. I'm done. Whoever joined, thank you. Goodbye. I'll do these easy problems for maybe a week or so, and then I'll switch to medium. These easy doesn't matter. This is just to get the groove going. Easy doesn't matter. Nobody asks easy questions. Alrighty.